Hello, in this lecture we find out the area of a circle using two different methods. In the drawing we have a circle and we have also square ABCD. This is line segment AP that is equal to 1 unit in its length. This is line segment QC that is equal to 4 units in its length. Again, our mission is to find out the area of this circle. So we start with the first method. First of all, we know that all those four angles inside square ABCD are right angles. So I'll show you, this is a right angle. This is also a right angle. This is a right angle. And this is a right angle. In the next step, we define the center of this circle. This point is point O. In addition, we define the point of tendency of tangent AB. This is tangent AB with this circle. This point is point S. And we join points O and S together by a straight line. Point O is the center of the circle. Point S is the point of the circle itself. Therefore, OS is the radius of a circle. We define the radius of the circle. We define the radius of this circle as x. So OS equals to x. When it's in its length, it is the radius of the circle. So here we can implement rule 1. I repeat quickly on rule 1. According to rule 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So in the drawing, we have a circle. This is tangent AB, that is tangent to this circle, and this point M. Point M is the point of tendency of tangent AB with this circle. In addition, we have the radius OM that is equals to R. The radius OM is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever your radius is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to this rule, rule 1. So I can actually implement rule 1 in our drawing. Why? Because in our drawing, we have the radius OS that is equal to x. The radius OS is drawn to point S, that is the point of tendency of tangent AB with this circle. And whenever your radius is drawn to the point of tendency, then tangent AB will be perpendicular to the radius SO. If AB is perpendicular to SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and Q together by a straight line. Point Q is the point of tendency of tangent BC with this circle. OQ is of course the radius of this circle, is equal to x. Here we can implement again rule 1. Why? Because the radius OQ that is equal to x, the radius OQ is drawn to point Q, that is the point of tendency of tangent BC with this circle. And whenever your radius is drawn to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule, rule 1. By doing these constructions, we're going to do quadrangular SOQB. Inside this quadrangular SOQB, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this 4th facing angle, in total they must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrangular is equal to 360 degrees. And therefore this 4th facing angle must be equal to 90 degrees in its size. So inside quadrilateral SOQB we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be this rectangle if not a square. So we relate to quadrilateral SOQB is rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle SOQB, side SO must be equal to the opposite side QB. But SO is x, therefore QB must be also equal to x units in its length. Likewise, according to the same rule, in the same rectangle SOQB, side OQ must be equal to the opposite side SB. But OQ is x, therefore SB must be also equal to x units in its length. So if you found out that quadrilateral SOQB is not a rectangle but a square, why? Because of the fact that all of its sides are equal to each other. All the sides of this square SOQB is equal to x. Are equal to x. Okay, we know that in square ABCD, all of its sides are equal to each other. That is to say side AB equals to side BC equals to side CD equals to side DA. And especially side AB equals to side BC in square ABCD. So I'll write it down. In square ABCD, side AB equals to side BC. AB equals to AS plus SB. AB equals to AS plus SB, and here AB equals to BC. So BC equals to BQ plus QC. Again, BC equals to BQ plus QC. BC equals to BQ plus QC. So in total, according to equation 1, we have found out that AS plus SB equals to BQ plus QC. AS is the missing side, so we leave it as it is, plus SB. SB is x, and it is equal to BQ. BQ is also x, plus QC. QC is 3 units in its length, according to what is given in the question. So according to equation 1, in total we have found out that AS plus x equals to x plus 3. Here we subtract x from this equation, equation 1. So x will get cancelled, and we left only with AS that is equal to 3 units in its length. So if we found out that the length of the missing 970 AS is actually equal to 3 units. This is 970 AS that is equal to 3 units in its length. In the next step, we will do a construction. That is to say, from this point P, we will go perpendicular on the radius SO. Again, from point P, we will go perpendicular on the radius SO. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point P and side SO. This point is point N. By doing this construction, we're going to do quadrilateral AP and S. Inside this quadrilateral AP and S, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees. According to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this fourth missing angle must be equal to 90 degrees in its size. So inside the small quadrilateral AP and S, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be a rectangle, not a square. So we relate to this form quadrilateral AP and S as a rectangle because it has 4 right angles. So this is quadrilateral AP and S, and it is a rectangle according to rule 5. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle AP and S, side AP must be equal to the opposite side NS. But AP is 1, therefore NS must be also equal to 1 unit in itself. Likewise, according to the sum rule, in the sum rectangle AP and S, side AS must be equal to the opposite side NP. But AS is 3, therefore NP must be also equal to 4 units in its length. What is the length of the missing 97 NO? The moment it is very easy to see that NO in total equals to SO minus SN. Again, NO equals to SO minus SN. So I write it down. NO is equal to SO minus SN. So NO is equal to SO. SO is the radius of the circle that is equal to X minus Sn. Sn equals to 1. So in total, NO equals to X minus 1 units in its length. So this is line segment NO that is equal to X minus 1 units in its length. In the next step, we join points P and O together by a straight line. PO is of course the radius of this circle that is equal to X. So in the next step, I'll copy this white green triangle P and O in a new page, and we'll implement the Pythagoras theorem on this green white triangle P and O. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here by PT is the relation for Pythagoras theorem. So actually, this is the right green triangle P and O that I call it from the original drawing according to the Pythagoras theorem. In this right triangle P and O, PO squared, that is the square of the hypotenuse, equals to PN squared plus NO squared. So I write it down. PO squared, that is the square of the hypotenuse, is equal to PN squared PO square equals to PN square plus NO square. PO is x, therefore PO square is x square, and it is equal to PN square. PN is 3, therefore PN square is 3 squared, that is 9, plus NO square. NO is x minus 1, therefore NO square is x minus 1 squared. So total we found out that x squared equals to 9 plus x minus 1 squared. So x squared equals to 9 plus x minus 1 squared. X minus 1 squared equals to x squared plus 1 squared, that is 1, minus 2 times x times 1, that is minus 2x. So here we have x squared on both sides of the equation, so x squared is cancelled. After cancelled x squared, on this side of the equation we left with nothing, that is to say 0. On the other side of the equation we left with 9 plus 1, that is 10, minus 2x. So in total we found out that 0 equals to 10 minus 2x. Here we add 2x to this equation, and we get that 2x equals to 10. Here we divide this equation by 2, and finally get that x equals to 10 over 2, that is 5. So if we found out that the length of the approach PO with x is 5 units, x is also the radius of this circle, so the radius of this circle, x equals to 5 units in its time. Our mission is to find out the area of this circle. Actually, the area of any circle is equal to pi times the radius of the circle squared. Again, the area of any circle equals to pi times the radius of the circle squared. And therefore, the area of our circle must be equal to pi times the radius of our circle squared. The radius of our circle is x, therefore the radius squared is x squared. So the area of our circle must be equal to pi x squared. So it is pi times x squared. Pi times x squared. X is 5, therefore x squared is 5 squared. So the area of our circle must be equal to pi times 5 squared. 5 squared is 25. So in total this expression equals to 25 pi. 25 pi is 78.54 square units. So we actually found out that the area that we're looking for in this question, that is the area of this circle, it is equal to either 25 pi square units, so in terms of numbers, the area of this circle equals to 78.54 square units. So we finished with the first method. In the next step, I will present to you how to find out the area of this circle according to the second method. So first of all, we know that ABCD is a square, therefore all those 4 angles inside square ABCD are right angles. So actually this is a right angle. This is also a right angle. This is a right angle. And this is also a right angle. In the next step, we define the center of this circle. This point is point O. We define the point of tendency of tangent AB with this circle. This point is point S. In the next step, we focus on this common sub point, point B. From this common sub point, point B, we have 2 tangents to this circle, tangent BS and tangent BQ. And according to all 2, they are equal to each other. That is to say, BS equals to BQ. So I think we can all 2. According to all 2, the lengths of 2 tangents from a common sub point to a circle are equal. So in the drawing we have a circle. This is the convex line point P. From this convex line point P, we have two tangents to the circle, tangent PA and tangent PB. And according to this rule 2, they are equal to each other. That is to say, PA equals to PB. So we can actually implement rule 2 in our drawing. In our drawing, as I already mentioned before, this is the convex line point B. From this convex line point B, we have two tangents to the circle, tangent BS and tangent BQ. And according to rule 2, they are equal to each other. That is to say, BS equals to BQ. So I write it down. BS equals to BQ according to rule 2. So if we define the length of this tangent BS as x, then the length of this tangent BQ must be also equal to x because they are equal to each other. We know that all the sides of square ABCD are equal to each other, and especially side AB equals to side BC. So I write it now. In square ABCD, side AB equals to side BC. AB in total is equals to AS plus SB. AB equals to AS plus SB. So AB equals to BC. BC in total equals to BQ plus QC. Again, BC equals to BQ plus QC. BC equals to BQ plus QC. AS is the missing side, so leave it as it is. Plus SB. SB equals to X. And it is equal to BQ. BQ also equals to X. Plus QC. QC equals to fluorescence length according to what is going to answer the question. So in total, according to equation 1, we actually found out that AS plus X equals to X plus 3. Here we subtract X, what is the equation 1. So X will get cancelled, and we're left only with AS that is equal to 3 units in its length. So actually, this is 970 AS that is equal to 3 units in its length. In the next step, we'll extend side AD of square ABCD by a straight line until it touches the circle. And we will define the touching point of the extended side AD with this circle, this point is point M. In the next step, we'll focus on this convex line point A. From this convex line point A, we have tangent AS, that is tangent to this circle at point S, and from the same convex line point A, if we draw this straight line, then it will cut the circle at 2 points, point P and point M. In this way, we create chord PM. So in total, from the same convex line point A, we have tangent AS and also M here, chord PM. And therefore, we can implement here rule 10. So effectively on rule 10, rule 10 is true in any circle. In any circle, if AB is any chord, AB is a chord inside the circle, and PT is a tangent to the circle. This is tangent PT, that is tangent to this circle at this point T. So So in this drawing, the following equation is true, that pt squared equals to pa times pb. Again, pt squared equals to pa times pb. So if we can say that according to rule 10, whenever you have a common extent point P, for example, and from the common extent point P, you draw tangent PT, and from the same common extent point P, you draw this straight line that cuts the circle at 2 points, point A and point B, in this way created here called AB. Then the following equation will be true, that pt squared equals to pa times pb. Again, pt squared equals to pa plus pb. So we can actually implement rule 10 in our drawing. Why? Because in our drawing, so as I already mentioned before, from this common extent point A, we have tangent AS, and from the same common extent point A, if you draw this straight line, it will cut the circle at 2 points, point P and point M. So all the requirements of rule 10 are satisfied, and therefore we can implement here rule 10. According to rule 10, the following equation is true, that AS squared equals to AP times AM. Again, AS squared equals to AP times AM. So I write it down. AS squared equals to AP times AM. According to rule 10, AS is 3, therefore AS squared is 3 squared, that is 9. And it is equal to AP. AP is 1 times AM. AM in total equals to AP plus PM. AM equals to AP plus PM. So according to 10, if we found out that 9 equals to 1 times AP plus PM. Because of the fact that anything that is multiplied by 1 will not change its value, any expression that is multiplied by 1 will not change the value of the expression. You can implement, you can ignore 1 with multiply AP and PM. And therefore this equation will be 9 equals to AP plus PM. So 9 equals to 9 equals to AP. AP is 1 plus PM. Here we subtract 1 from this equation and you get that PM equals to 9 minus 1, that is 8. So if we found out that the length of this chord PM is equal to 8 units. In the next step, we will do a construction. This is to say, from this point O, that is the center of this circle, we will draw perpendicular on chord PM. Again, from point O, that is the center of this circle, we will draw perpendicular on chord PM. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O, and this chord PM, this point is point N. So actually, from the center of this circle, that is to say point O, we draw perpendicular ON on chord PM. Again, from the center of this circle, we draw perpendicular on chord PM. And therefore, you can implement here rule 11. Whenever we draw from the center of the circle perpendicular towards any chord, you can implement rule 11. So according to rule 11, the perpendicular to a chord drawn from the center of the circle bisects the chord. So in the drawing we have a circle. This is point O, that is the center of the circle. So from point O, we draw perpendicular OM on chord AB. Again, from point O, that is the center of the circle, we draw perpendicular OM on chord AB. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. And according to this rule 11, perpendicular OM bisect chord AB. Again, perpendicular OM bisect chord AB. That is to say, perpendicular OM divides chord AB into two halves. Each half equals to AB over 2. So the first half is AM, is equal to AB over 2, and the second half is AB, that is also equal to AB over 2. So according to rule 11, the first half is AM, and it is equal to the second half, that is MB, and each half equals to AB over 2. We can definitely implement rule 11 in our drawing. In our drawing, from the center of this circle, that is to say from this point O, we draw perpendicular on chord PM. Again, from point O, this is the center of the circle, we draw perpendicular on chord PM. So all the requirements of rule 10 of rule 11 are satisfied, and therefore we can implement rule 11. According to rule 11, perpendicular ON that is drawn from point O, that is the center of the circle, bisects chord PM. That is to say, perpendicular ON divides chord PM into two halves. Each half equals to PM over 2. So the first half is PN, and it is equals to the second half, that is NM, and each half equals to PM over 2. So I'll write it down. According to rule 11, perpendicular ON, that is one from point O, that is the center of the circle, bisect chord PM. That is to say, divides chord PM into two halves. The first half is PN, and it of course equals to the second half, that is NM, and each half equals to PM over 2. So according to rule 11, we can find out that Pn equals to Nm equals to Pm over 2. But Pm is 8, therefore Pm over 2 is 8 over 2, that is 4. And from this long equation, Pn equals to Nm equals to Pm over 2 equals to 8 over 2 equals to 4, we'll derive that Pn equals to 4 units in its length. So Pn equals to 4 units in its length. So if I found out that the length of this line segment PN is equal to 4 units. In the next step, we will join points O and S together by a straight line. Point O is the center of this circle, point S is the point on the circle itself, therefore OS is the radius of this circle. So I write it down. OS is the radius of this circle. Because of the fact that the radius OS is drawn to point S, that is the point of tendency of tangent AB with this circle, and whenever your radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius SO. If AB is perpendicular to SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. So by doing this construction, we get the quadrilateral AN OS. Inside this quadrilateral AN OS, we have 1, 2, 3 lattices. The sum of 3 right angles is 270 degrees, so 270 degrees plus the side of this fourth missing angle. In total, they must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore, this fourth missing angle must be equal to 90 degrees in its size. So inside quadrilateral ANOS, we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be this right angle plus a square. So in order to this quadrilateral ANOS as right angle, because it has 4 right angles. So now let it know. This is quadrilateral ANOS. That is a rectangle according to rule 5. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle ANOS, side AN must be equal to the opposite side OS. But AN is 4, therefore AN in total equals to 1 plus 4, that is 5. So AN is 5, therefore OS must be also equal to 5 units in its length. But OS is the radius of the circle, and therefore the radius of the circle equals to 5 units in its length. It again. The radius of this circle is equal to 5 units in its length. Our mission is to find out the area of this circle. Actually, the area of any circle, as I already mentioned before, the area of any circle is equal to pi times the radius of the circle squared. The area of any circle equals to pi times the radius of the circle squared. And therefore, the area of our circle must be equal to pi times the radius of our circle, that is 5 squared. So it is pi times 5 squared. 5 squared is 25, so in total this expression equals to 25 pi. 25 pi is 78.54 square units. So actually, in both methods, we found out that the area of the circle, that is the area that we are looking for in this question, is equals to either 25 pi square units, so in terms of numbers, it is equal to 78.54 square units. So in the next step, I'll summarize the lecture. We start with the first method. Our mission in this lecture is to find out the area of this circle. We actually found out the area of this circle using 2 different methods. So we start with the first method. In the drawing we have a circle, and we also have here square ABCD. This is line segment AB, that is equal to 1 unit in its length. This is line segment QC, that is equal to 2 units in its length. Again, our mission is to find out the area of this circle. So first of all, we know that all the angles inside square ABCD are right angles. So those 4 angles are all right angles. In the next step, we define the center of this circle. This point is point O. In addition, we define the point of tendency of tangent AB with this circle. This point is point S. In the next step, we join points O and S together by side line. OS is the radius of this circle. We define the radius of this circle as X. We can implement here rule 1. Why? Because the radius of S is drawn to point S, that is the point of tendency of tangent AB with this circle. And whenever your radius is drawn to the point of tendency, then tangent AB will be perpendicular to the radius SO. If AB is perpendicular to SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and Q together by side line. OQ is, of course, the radius of this circle. This is equal to X. The radius of Q is drawn to point Q, that is the point of tendency of tangent BC with this circle. Whenever your radius is drawn to the point of tendency, then according to rule 1, tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule, rule 1. So by doing these constructions, we can do quadrangle OSBQ. Inside this quadrangle OSBQ, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total the must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrangle is equal to 360 degrees. And therefore this fourth missing angle must be equal to 90 degrees in its size. So inside quadrangle SOQB we have 4 right angles. And according to rule 5, any quadrangle that has 4 right angles must be its right angle in front of square. So in order to this quadrangle SOQB is a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle SOQB, side SO must be equal to the opposite side QB. But SO is x, therefore QB must be also equal to x units in its length. Likewise, according to the same rule, in the same rectangle SOQB, side OQ must be equal to the opposite side SB. But OQ is x, therefore SB must be also equal to x units in its length. So if you found out that quadrangle SOQB is not a rectangle but a square, why? Because of the fact that all of its sides are equal to each other, each side of this square SOQB is equal to x units in its length. We know that all the sides of square ABCD are equal to each other. That is to say, side AB equals to side BC equals to side CD equals to side DA. And especially side AB equals to side BC. So repeat again, in square ABCD, side AB equals to side BC. AB in total equals to AS plus SB. Again, AB is AS plus SB, and it is equals to BC. BC in total equals to BQ plus QC. Again, BC equals to BQ plus QC. So in total, according to equation 1, we actually found out that AS plus SB equals to BQ plus QC. AS is the missing side, so we leave it as it is, plus SB, SB is x, and it is equal to BQ, it is also x, plus QC, that is 3. So in total, according to equation 1, we found out that AS plus x equals to x plus 3. Here we substitute x for this equation, so x will get cancelled, and we're left only with AS that is equal to 4 units in its length. So this is the missing line segment AS that is equal to 4 units in its length. In the next step, we did a construction, that is to say, from this point P, we go perpendicular on the radius SO. Again, from point P, we go perpendicular on the radius SO. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the construction. We define the touching point of the perpendicular from point P, and side SO. This point is point N. By doing this construction, we can deduce the small quadrangle AP and S. Inside the small quadrangle AP and S, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle. In total, they must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrangle is equal to 360 degrees. And therefore, this fourth missing angle must be equal to 90 degrees in its size. So inside the small quadrangle AP and S, we have 4 right angles, and according to rule 5, any quadrangle that has 4 right angles must be its rectangle in front of the square. So in order to this small quadrangle AP and S is a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in the small rectangle AP and S, side AP must be equal to the opposite side NS. But AP is 1, therefore NS must be also equal to 1 unit in its length. Likewise, according to the same rule, in the same rectangle AP and S, side AS must be equal to the opposite side NP. But AS is 3, therefore NP must be also equal to 4 units in its length. What is the length of this? This is 97 NO, NO equals to SO minus SN. Again, NO equals to SO minus SN. SO is the radius of this again, that is x, SN is 1. So in total, NO equals to x minus 1 units in its length. NO equals to x minus 1 units in its length. In the next step, we join points P and O together by side line. PO is the radius of this circle, that is equal to x. So in the next step, I complete this green right triangle P and O in a new page, and we implemented the Pythagoras theorem, this green right triangle P and O. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So finally, this is right green triangle P and O, that according to the original domain, according to the Pythagoras theorem, in this right triangle P and O, PO squared, it is the square of the hypotenuse, PO squared, it is the square of the hypotenuse, equals to Pn squared plus NO squared. PO is x, therefore PO squared is x squared, it is equal to Pn squared. Pn is 3, therefore Pn squared is 3 squared, that is 9, plus N O square. NO is x minus 1, therefore NO square is x minus 1 square. So in total, according to the Pythagoras theorem, we found out that in the right triangle PNO, x square equals to 9 plus x minus 1 square. So x square equals to 9 plus x minus 1 square. X minus 1 square equals to x square plus 1 square, that is 1 minus 2 times x times 1, that is minus 2x. We have x square on both sides of the equation, so x square gets cancelled, we cancel x square. On this side of the equation we left with nothing, that is to say 0. On the other side of the equation we left with 9 plus 1, that is 10 minus 2x. So in total we found out that 0 equals to 10 minus 2x. We added 2x to this equation, and finally found out that 2x equals to 10. Here we divided this equation by 2, and finally found out that x equals to 10 over 2, that is 5. So actually the radius of this circle x equals to 5 units in its length. Our mission is to find out the area of this circle. Actually the area of any circle equals to pi times the radius of the circle squared. And therefore the area of our circle must equal to pi times the radius of our circle squared. The radius of our circle is x, therefore the radius squared is x squared. So in total the area of our circle must be equal to pi x squared. X is 5, therefore x squared is 5 squared. So in total the area of our circle must be equal to pi times 5 squared. 5 squared is 25, so in total this expression equals to 25 pi. 25 pi is 78.54. So in total we found out the area that we are looking for in this question, that is the area of this circle equals to either 25 pi square units. So in terms of numbers, the area of this circle is equal to 78.54 square units. We finish with the first method. In the next step I presented to you how to find out the area of this circle according to the second method. So first of all, we know that ABCD is a square, therefore all those 4 angles are right angles. We define the center of this circle, this point is point O. We define the point of tendency of tangent AB with this circle, this point is point S. In the next step we focus on this common sum point, point B. From this common sum point, point B, we have tangent BS and tangent BQ. According to rule 2, they are equal to each other. That is to say, BS equals to BQ. Again, BS equals to BQ according to rule 2. So if we define the length of this tangent BS as x, then BQ must be also equal to x because they are equal to each other according to rule 2. We know that all the sides of square ABCD are equal to each other. That is to say, side AB equals to side BC. Repeat again. In square ABCD, side AB equals to side BC. AB equals to AS plus SB. Again, AB equals to AS plus SB is equal to BC. BC in total equals to BQ plus QC. BC equals to BQ plus QC. So in total, according to equation 1, we can find out that AS plus SB equals to BQ plus QC. AS is the missing side, so we leave it as it is. So it is AS plus SB. SB is X. And it is equal to BQ. BQ is also X plus QC. QC is 3. So in total, according to equation 1, we actually found out that AS plus X equals to X plus 3. Here we substitute X from the equation equation 1. So x will get cancelled, we left only with AS that is equal to 3 units in its length. So this is the missing line segment AS that is equal to 3 units in its length. In the next step, we extended side AD of this square ABCD by a straight line until it touches the circle. We define this touching point of the extended side AD with this circle, this point is point M. In the next step, we focus on this common sum point, point A. From this common sum point, point A, we have a tangent AS, and from the same common sum point, point A, if we draw a straight line, it will cut the circle 2 points, point P and point M. In this way, we create chord PM. So all the requirements of rule 10 are satisfied, and therefore we can implement rule 10. According to rule 10, the following equation is true, that AS square equals to AP times AM. Again, AS square equals to AP times AM. So if we focus on the common sum point, point A, according to rule 10, the following equation is true, that AS square equals to AP times AM. AS is 3, therefore AS square is 3 squared, that is 9, and it is equal to AP. AP is 1 times AM. AM total equals to AP plus AM. Again, AP is 1 and AM equals to AP plus PM. So in total, 9 equals to 1 times AP plus PM. Here we can ignore 1 because any expression that is multiplied by 1 will not change its value. So this equation equals to, so we ignore 1, 9 equals to AP plus PM. Again, that 9 equals to AP plus PM. So 9 equals to AP, AP is 1, so 9 equals to 1 plus PM. Here we subtract 1 from this equation and find out that the missing 4 PM is equal to 9 minus 1, that is 8. So this is the missing 4 PM, that is equal to 8 units in its length. In the next step we did the construction, that is, and to say from this point O, that is the center of this circle, we go perpendicular on chord PM. Again, from point O, we go perpendicular on chord PM. So here this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. And whenever you draw a perpendicular from the center of the circle towards any chord, according to rule 11, it will bisect the chord. So according to rule 11, the perpendicular ON, that is one from point O, that is the center of the circle, will bisect chord PM. If perpendicular ON bisects chord PM, it means that perpendicular ON divides chord PM into two halves. Each half equals to PM over 2. So the first half is PN, and it is of course equals to the second half, that is NM, and each half equals to PM over 2. According to rule 11, perpendicular ON bisects chord PM into two halves. The first half is PN, and it is equal to the second half, that is NM, and each half equals to PM over 2. PM is 8, therefore PM over 2 is 8 over 2, that is 4. From this equation, we draw that Pn equals to 4 units in its length. Pn equals to 4. So here, this is 97 Pn, that is equals to 4 units in its length. In the next step, we join points O and S together by straight line. Point O is the center of the circle, point S is the point of the circle itself, therefore OS is the radius of this circle. Because of the fact that the radius OS is drawn to point S, that is the point of tendency of tangent AB with this circle. Whenever your radius is drawn to the point of tendency, then tangent AB will be perpendicular to the radius SO. If AB is perpendicular to SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. By doing this construction, we can edit quadrilateral ANOS. Inside this quadrilateral ANOS, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the side of this fourth missing angle. In total, they must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore, this fourth missing angle must be equal to 90 degrees in inside. So inside quadrilateral ANOS, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be this rectangle not a square. So we relate to quadrilateral ANOS as a rectangle because it has 4 right angles. So quadrilateral ANOS is a rectangle according to rule 5. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle ANOS, side AN must be equal to the opposite side OS. But AN in total equals to 1 plus 4, that is 5, therefore the opposite side OS must be also equal to 5 units in its length. But OS is the radius of the circle, therefore the radius of the circle is equal to 5 units in its length. Our mission is to find out the area of this circle. Actually, the area of any circle is equal to pi times the radius of the circle squared, and therefore the area of our circle must be equal to pi times the radius of our circle squared. The radius of our circle is 5, and therefore the radius squared is 5 squared. So 5 squared is 25, so in total this expression equals to 25 pi. 25 pi is 78.54. So in both methods, we found out that the area that we are looking for in this question, that is the area of this circle, it is equal to either 25 pi square units, or in terms of numbers, the area of this circle is equal to 78.54 square units. Okay, thank you very much.